And we're back. So let's look at, so I left off talking about macrophages and T helper cells. So let's look at these two. Macrophages, so remember we had this macrophage and it was displaying a portion of the virus that it had eaten. I like giving stuff faces. So this is your macrophage. And then we have a T helper cell over here. Let's try it in a different color. So we have the T helper cell. T helper cell. And the T helper cell has latched on with a receptor. And when it does that, then it secretes or releases, I should say, these cytokines. These cytokines are messages to the outside, sends out a message to the rest of the white blood cells. Come help, come help. This guy has a virus. Come help. So then other cells, like more cells, like B cells. So I'm going to have a B cell come. And it's going to come and it wants to kill, there's a message out there that viruses have invaded. So the rest of the immune system is going to come and help. Because these immune cells, they can sense those cytokines. And these are cytokines. Cytokines are chemical messengers or chemical signals. Okay. Not only do B cells sense or smell those cytokines, so do many other white blood cells. I'm going to draw a cytotoxic killer cell. This is cytotoxic T killer cell. It also can smell or sense those cytokines, and it comes. It's a lot of cytokines. And these cells, they start to spew more cytokines. So then more help will come, more white blood cells. You get more and more cytokines, and something can happen called a cytokine storm, where there's just a lot of cytokines. But what do these things do? Where are these white blood cells coming from? They're actually, so let's make this a portion, let's make this inside of a lung. So if we're in a lung, there's two types of lung cells. One of them makes surfactant, which is just a soap. But the other lung cell is responsible for gas exchange. So there's two types of lung cells. One of them makes a fat or a soap called surfactant. And the other one does gas exchange. And that's really important, gas exchange. What gases are exchanged? Well, oxygen goes in, O2, or oxygen, and then CO2 goes out, and we breathe it out. Right here, well, where is this oxygen going to? If we're in a lung, let's draw a capillary, very close. So the capillaries are lined with epithelial cells, just single cell, squamous cells. And they're pretty tight. They're pretty close to one another, these cells. But when the cytokines start to be released, a B cell wants to get in because white blood cells live in your blood. So the white blood cells are here and they want to come in and help with the fight. So the capillaries have to make room so that the white blood cell can get through. And the white blood cell can come fight the invader, right? But also, it's not just the white blood cell. So when the capillary cells move, fluid can get in. So that fluid is plasma. So fluid gets in, and fluid fills the lung. And that's the problem when someone has SARS-CoV-2, is this fluid starts to fill the lungs. And if the fluid fills the lung, then it's hard for this gas exchange to happen. And that is called ARDS. It's acute respiratory distress syndrome. So that's why people need to be put on ventilators, because now their lungs can't do the gas exchange, but the machine helps take over where the lungs are no longer working efficiently. And it all started because of the viruses entering into the lung cells. Thank you so much, and I will post papers and the chapter in Campbell so you guys can read more about this. This was really quick, it was an overview, but go to those materials and you can fill in the details. Okay, I will see you guys on Zoom. Bye-bye.